Hello everyone, I am Abhay Singh and in this video I'll be discussing about exploratory data analysis which will include how to construct a bar graph with overlay, how to construct contingency tables, how to construct histograms with overlays, and how to perform binning based on predictive values. So let's begin with how to construct a bar graph using overlays. So first let's what is a bar graph? So bar graph are a great way to visualize categorical data. We can add an overlay like an additional line or bar to show relationships on comparison. Overlaying multiple data sets on a single bar graph allows you to compare and contrast different sets of data simultaneously. We'll use the matplotlib and seaborn libraries to create a bar graph with an overlay line. So here is the code for bar graph visualization in which we have imported matplotlib.plotlib, which is a module for matplotlib as PLT. And next we have imported Seaborn as SNS. And then we have imported Panda library. So we'll begin with sampling the data in which we have taken variable as data is equals to pd.dataframe, and pd.dataframe is used for arranging data in the form of columns in which we have key values, category, count, and other count, which will be arranged in the form of columns. And here we are plotting bar graph by count by category in which we have taken sns.barplot. So SNS is a library which is used for data visualization in which we have taken X as a category, Y coordinate as count, and we have taken color as sky blue and label as count. So plt.plot is used for plotting the datas of categories in on x-axis and the datas that are included in the other count as data and color as orange. So here we are adding labels on the titles. So here are the labels, count, categories, and bar graph with overlays, in which the syntax is plt.xlabel category, in which we are on the x-axis we are plotting category. Here is the category, and on the y we are plotting count. Here is the count, and on the title we are putting bar graph with overlays. Here is bar graph with overlays. Then plt.show for showing our bar graph. In this output, the output shows a bar graph with each category has a blue bar. Here are the blue bars representing counts, and an orange line with marker overlays the bars showing other counts. Then here are the other counts, and this bar graph with an overlays allows us to compare two sets of data on the same chart. The bar graph represents count per category, and the orange lines shows other count, making it easy to spot trends. Next we have is how to construct contingency tables using Python. So what is a contingency table? A contingency table, also known as cross tabulation or crosstab, is a tabular representation of categorical data. It displays the frequency distribution of two or more categorical values. Each cell in the table represents the frequency of a particular combination of categories. We'll use Panda library to construct a contingency table. So contingency table are a powerful tool for analyzing the relationship between categorical variables that helps us to understand the following things. First we have is frequency distribution, which means that how often different combinations of categories occur. Independence, which means that whether two categorical values are independent or associated. Third we have is conditional probability, which means the probability of one event given the another event has occurred. Then fourth we have is trend analysis, which means that identifying trends or patterns in the data over time or across different groups. Here is the code for how to construct a contingency table. And we have taken data variable as pd.dataframe, which will arrange the gender and preference in the form of two columns, which will include values such as male, female, and the same two values and AA. And here we are creating a contingency table in which we have taken variable name as contingency underscore table is equals to pd.crosstab. So here pd.crosstab in Panda is used to create a cross tabulation table which summarizes data by showing the frequency or the count between two or more categorical values. And here two values of variables are gender or preferences. And now here we are printing our contingency table. So our of contingency table will be in the form of this format, in which female has occurred 1 and 2 times in set 1A and male 2 and 1. So this table shows gender group preferences on the base of two categories A and B. So contingency tables like this are great for spotting relationships between two categorical values. In this we had gender and preferences, and how often our tests like chi-square are correct. Next we have is constructing histograms with overlays using Python. So what are histograms? Histograms with overlays are powerful for comparing the distribution of multiple variables on the same plot. A histogram is a graphical representation of distribution of numerical data and divides the data into bins, which are internal intervals, and then count the number of data points that fell into each bin. The height of each bar in the histogram represents the frequency or the density of the data points within the each bin. Here we use in visualization numerical data distribution, which includes central tendency, which means the center or the middle of the data, which includes mean, median, mode. Next, we have a dispersion, which means the spread or variability of the data, which includes range, variance, and standard deviation. Third, we have is shape, which means the overall shape of the distribution, which means the symmetric, skewed, or normal. Fourth, we have is outliners, which means the data points that are significantly different from the rest. Then we will use Seaborn to plot overlaid histograms, making it easier to see if two distribution overlay or differ. And here is the code for histogram, in which we have imported library numpy as np, and here we are generating sample data. In first data we have is np.randomNormal, which is used for randomly generate the number that follows normal distribution, in which we have is 25 and 10. And dataset 2 we have is np.random.normal, which is again used for randomly generating numbers that follows normal distribution, which include 3, 5, and 10. And here making a histogram with overlays, so in which we have is plt.figure. So in which figure size is 8 and 6. It means that the plot plt.figure function is used to create figure for plotting. It allows you to define the size, resolution, and other properties of the figure before you plot any graph. Here we have is sns dot his plot. In here, SNS is a library for data visualization, in which we had one, in which we have color blue, label as dataset 1, and bins equals to 50 and KDE is equals to true. And then we have SNS dot his plot data 2, in which will all the included the data of set 2, which are 35 and 10, and the color is orange, label is data 2, bin equals to 15, and alpha is equals to 0.5. And plt.x label is used to put label on the x-axis, which is values. plt.y label frequency, in which on the y-axis the frequency will be shown. And plt.title is used for putting the title on the graph, which is histogram with overlays. And then we will show our histogram. So here is the histogram, in which we have taken on the x-axis we have taken values, on the y-axis we have taken frequency, and as a title we have taken histogram with overlays. So this generates a histogram with two distribution overlaid, where data 1 is blue. Here is the data 1, which is blue, and data 2 is orange. It is orange in the orange color around a clear comparison. With overlaid histogram, you can instantly spot difference with overlays in the distribution of multiple data sets. This is valuable for understanding how different groups vary. Okay, so next we have is performing binning based on predictive values. So what is binning? Binning is a process of grouping numerical values into bins or intervals. Binning based on predictive values means choosing bin range that can be useful for prediction. Binning, also known as discretization and quantization, is a data preprocessing technique that involves grouping numerical values into smaller intervals or bins. This is often done to simplify data, reduce noise, and improve the performance of certain data mining algorithms. So, what is the purpose of binning? First is handling outliners, which means binning can be helped to mitigate the impact of outliers, which can distort statistical measures and affect model performance. Second, we have is reducing data sparsity. For categorical variables with many levels, binning can reduce the number of categories, leading to more stable models. Third purpose we have is improving model performance. In this, binning can improve the performance of machine learning algorithms, especially when dealing with continuous numerical values. So here we have code for performing binning based on predictive model. We will use panda.cut to create bins and examine how each bin relates to another variable. And we are here taking sample data in which we have variable as data, which is equals to pd.data frame, which will arrange these key values in the form of two columns, age and income value, in which age will include 22, 25, 47, etc. And income level will increase 20,000, 22,000, and etc. And in this portion, we are defining bins based on age ranges that might be relevant for income prediction, in which we have taken bin as 20, 30, 40, 60, and 70. And we have taken labels as 20 to 30, values that are in between 20 and 30, values that are between 13 and 14, between 40 and 50, and etc. And here we have taken data from the age set, age group is equals to pt.cut, and we have taken age and bins equals to bin. And here we are calculating mean income by age group, in which we have taken income by age group is equals to data.group by age group, then income level and mean for calculating the mean of age group and income level. And here we are printing average income by group, and here will be our output. From 20 to 30 we have this, and 30 to 40 we have this. So by binning ages into group and examining incomes per group, we gain insights into how age relevance to income. And this kind of binning is helpful for understanding trends and building predictive models. So this wraps up our tutorial and explanatory data analysis with Python. We went through the constructing bar graphs and histograms with overlays, creating contingency tables, and using bins to reveal predictive tables. So this was all about this topic and this video. I hope you liked the video. Thank you.